Guys, it's me again. Unfortunately, we have to talk about the Cascadia Fault again. And guys, trust me, I really don't like it because this scares me because I'm sitting right in the danger zone. So it's me again, live from the doomsday situation. The most dangerous West Coast fault line shows signs of potential megaquake after 324 years of silence. This is a paper that I found. I'm like, oh, I should read that because it affects me. And of course, I want to let you guys know about this too. So there's several new factors that the scientists have discovered that are alarming. So guys, I'll talk you through that while I'm sitting in a high-rise in the danger zone. So I guess I'm on the pulse for you guys. So if you value that, please leave this video an early like and hype, share it with your friends and subscribe if you're new here, and let's dive into this. Seafloor sensors have detected unexpected pressure changes, and pressure changes at subduction zones like the Cascadia Subduction Zone. That is not something that keeps my nerves calm, guys. I can tell you that. There's ocean bottom pressure sensors, pressure recorders. They're off the coast of the state of Washington. They have registered small but consistent fluctuations that, here comes, that differed from routine tidal cycles. So they're not normal. They're small, but that doesn't mean anything. I mean, in a way that it's small, forget about it. No, they're actually very meaningful. The timing, that's the issue as well. It has lined up with subtle deformation patterns that are measured onshore. So basically, the measurements are reconfirming each other. So according to the United States Geological Survey, the USGS, the combined signals suggest strain was increasing along, and here comes, the locked section of the fault. And we know what happens if a fault is locked and loaded and stress is building up. It's building up until boof, unfortunately. And we have a problem on the west coast of Canada and the US, guys. Watch this video. I put in the thumbnail wiped out because we have scientific evidence on the ocean floor discovered by coincidence. How? I'll tell you. Watch that video here. You see the thumbnail. I'll put it in the end screen. This is crazy. San Andreas Fault, Cascadia Fault, rupturing together, triggering each other. So when we're sitting here, west coast of Canada, west coast of the US, of Oregon and Washington, and we would hear that the overdue locked and loaded San Andreas Fault just triggered, we'd be like, San Andreas Fault doesn't go along our side. No, now the evidence is it has triggered the Cascadia Fault in the past and vice versa. Shortly after each other. Watch that video, guys. But let's talk about the big one, the Cascadia Fault. And for you that live in California, since that can trigger your fault, you should listen carefully. And you'll be affected by the monster tsunami that this thing will cause for sure. So we talked about accumulated strain on a subduction zone that is capable to produce a magnitude 9+ Megathrust disastrous earthquake with a tsunami wave that would come 8 to 15 minutes right after the quake. The quake would probably last for several minutes. The shoreline will sink probably 6 feet, and then the tsunami comes. So that's why scientists say if that happens and you're in the tsunami zone, run. And they're saying, do not turn around. Do not help anybody. It sounds cruel, but run. Get to higher ground as soon as you can. So the new data that they have accumulated right now, researchers realized the pressure shifts were not isolated events. not isolated. You know what I'm hinting at, guys. The slow buildup hinted at deeper movement that could not be seen from the surface. So these early tremors of strain, of course, right now did not indicate immediate danger, that, oh, it's coming in the next few hours. And no, but it's equally concerning because it confirmed that the quiet zone was slowly tightening. And we just recently talked in my other videos about the Pacific Ring of Fire. Cascadia Subduction Zone lies on the Pacific Ring of Fire, this horseshoe ring, and it's basically the most quiet area. We have disaster all around on the Pacific Ring of Fire. We just had the Kamchatka Megathrust earthquake, 8.8. I mean, I don't need to talk about Japan. We know what's happening there, but also in other areas. You see the Ring of Fire, you see the countries that are affected, but this Cascadia Subduction Zone hasn't done the big one for quite a while, and it's overdue. And when it will rupture, it will destroy the Pacific Northwest. We're talking about cities like Vancouver, Canada, Seattle, Portland, and of course the coastal communities as well. And as I mentioned, if the San Andreas Fault then gets triggered, good night, West Coast. Who's there to help if they're all destroyed? So, not isolated. GPS stations that were placed inland revealed creeping ground deformation. Ground deformation is something that I never like, not with fault lines and not with volcanoes. And these stations are high precision GPS stations. These stations are scattered across the state of Oregon, and they began to drift eastwards at a measurable rate. Measurable. Still, the shift was slight, but guys, there's the but. Here's the but. Consistent. They are consistent. Signaling, it's a subduction zone. One plate is sliding underneath the other. So that signals that the overriding plate was being pulled towards the continent as the fault continued to lock. We have confirmation of that from the Pacific Northwest Seismic Network. This slow motion deformation matches patterns, and here comes, I don't even want to say it because really, guys, honestly, it scares me. I repeat it. This slow motion deformation matched patterns seen before major subduction earthquakes worldwide. So the Cascadia Subduction Zone doesn't rupture often enough, thankfully, so that we would have a lot of data about it. We have evidence about it, geological evidence, but we don't have any data that we have recorded with modern instruments, but we do have that from other subduction zones. So we have the data that tell us before, for example, Kamchatka, before that Megathrust earthquake, this and this and this and this and this happened. Before the big earthquake in Japan that was creating this devastating tsunami in 2011, Tohoku earthquake, this and this and this and this happened. Japan is also due for another one in the Nankai Trough and in other areas. So I'm starting to sweat a little bit. I have to tell you, it's not that easy. I mean, I'm talking about disasters all around the world, geological anomalies, even up in the sky, 3i Atlas. But this affects the actual area where I'm sitting right now. So I have a little bit more emotion probably while I'm speaking about that. So over several months, they have noticed that the movement strengthened the case that stress was accumulating beneath the region. The land itself seemed to be leaning inwards with each passing week. So researchers noted this behavior as a sign that the system was entering a new phase of strain, one that demanded even closer monitoring, more monitoring that they're already doing. I don't hear much from Canada. What monitoring are they doing? I have a feeling from what I see, they're relying on the US. Although they're equally affected by this, they have core samples. they have deep core samples, and they found something there as well. So they can back up their theory with so many more pieces of evidence that make a bigger puzzle. And I'm telling you all about them. So number 3 is deep core samples, exposed evidence of past violent ruptures that were telling a story. Geologists were analyzing marsh and offshore sediment cores that they were taking, and they found layers of sand that was washed far inland. How can that happen? Well, my educated audience, you know how this happens, right? Tsunami. It's evidence left behind by ancient Cascadia tsunamis. We know the Ghost Forest in Washington. We know Nescoin Beach in Oregon, where we have the ghost stumps still on the beach. Several layers of sand that they found. They matched the devastating event of 1700, a Megathrust earthquake at the Cascadia Subduction Zone with the matching monster tsunami. Can go up as high as 100 feet. The Geological Society of America has discovered this evidence, by the way. So these records already gave researchers a clearer picture of the history of the fault and confirmed its capability of a sudden massive rupture. And we can see from these cores with layers, each core told a story of like calm periods broken by moments of extraordinary force. That's why people don't take it so serious here, because it's so calm. It's not like California that's been rattled all the time. Here, nothing, basically nothing. Smaller earthquake here and there. And that's why, if that sudden catastrophic release happens, I know here in Canada, the cities are not prepared at all. And even in the US, we talked about the building codes and stuff like this. So many unreinforced masonry buildings in Seattle and in Portland and in other areas. Victoria, the capital of British Columbia, Canada, will be a total mess. It's the worse than Vancouver. And scientists are now comparing modern data to ancient patterns. And the problem is the parallels that they see become harder to ignore, guys. And then there's another piece of evidence. Newly discovered tremor clusters hinted also at a shifting strain that is happening right now. We have clusters of low-frequency tremors, low-frequency earthquakes that appeared beneath southern Vancouver Island and coastal Oregon. And why were they happening in these areas? Well, they were marking areas that were adjusting quietly. And again, what I'm about to say now gives me shivers down my spine. These tremors often act as precursors to larger changes in the system. They signaled movement deeper within the subduction zone as the stress transferred slowly along the plate boundary. And if there's deeper movement, something's going on, other areas have to adjust. These tremors, when they happened, they did not threaten the communities directly, but their timing and the distribution helped the researchers map how strain traveled underground. And that's very important with such a monstrosity of subduction zone. And the clusters have highlighted sections of the fault that were beginning to slip in response to growing pressure. And that slip forms the earliest signs of shifting behavior. It doesn't get better. Wait for it, guys. Next one. Let's talk about the offshore fault mapping again. It has showed fresh signs of uplift. I don't like the word fresh at all, guys. I really don't. So recent surveys, also fresh surveys, they were using ship-mounted sonar, have revealed small uplift zones along the seafloor near the locked portion of the Cascadia Fault. Guys, uplift near the locked portion, and then the word Cascadia Fault. I'm starting to sweat, I have to say that. Because we do know Uplift occurs when stress builds up between the converging plates, causes the upper plate to bend upwards. This deformation is one of the clearest indicators that strain is accumulating faster than the plate can release it. Because if they are subducting and you push it and it gets locked here, but it's pushing from here, it starts to lift up because this is holding. But when this gives way, poof, the land will even go up in the air a little bit. It's a scary, scary thought. The uplift areas aligned with known locked segments that last ruptured in 1700. So this reactivation of these areas has really deepened the concerns that the quiet period that we're having right now in the beautiful Pacific Northwest may be reaching, how the scientists call it, its natural end point. The maps offered a visual record of the stress that is rising beneath the ocean, by the way. So we can see it. And something else is also confirming that something's going on there. I told you, pieces of a puzzle. It's not that they just found one thing and they're like, whoa. No, it's like this thing, that thing, this thing, that thing, this thing, huh? Changes in coastal groundwater levels have raised new concerns. Of course, changes in groundwater levels. That's great. So they have monitoring wells along the Oregon and Washington coastline, and they showed shift in groundwater pressure that correlated with subtle crustal deformation. Where else would this come from? So as the land is flexing under the strain, the water levels, of course, they're responding as well. And they responded in ways not previously seen during stable periods. So this is new. These shifts provide another indirect measure of stress building underground. Subduction zone. The problem is the communities that are there, they're relying on these wells, and their wells only saw minor fluctuations. But the researchers that are studying the data, they recognized a recognizable pattern, and that's never good. Similar groundwater movements have been documented in regions preparing for major subduction zone activity, speaking megathrust earthquakes, the biggest there are, or there is, how you say. You know what I mean. So these signals are also adding to the cluster of early warning signs. And really, I often think, because we're talking about Campi Flegrei, the supervolcano in Naples, Italy, where the people basically live on the volcano because it doesn't look like a volcano. It doesn't look like Vesuvius, a stratovolcano. And we're saying, gosh, why don't they evacuate? Why don't they leave? There's ground uplift, increased seismicity, increased gas releases. It's a little bit more like more action there, that the volcano's really telling them, whoa, right? Here it is quiet, but is there a big difference? Telling these people, well, get out while you can. Should I get out while I can? Really, this is, of course, I'm thinking about that. But where you move, then you move to another area, and then a tornado wipes out your home and you with you, or a hurricane, or whatever, right? But maybe the people in Italy think the same way. It's really difficult. But guys, that's not all. Another piece of the puzzle. Marine sediment began recording unusual compression patterns. Marine sediment, unusual compression patterns. Also not very reassuring. So they collected sediment layers near the continental shelf edge, and that revealed compaction changes associated with rising stress along the plate interface. And these layers are acting like geological memory cards. They're storing shifts that were happening too deep or too slowly for other sensors to capture. But they have captured them now. The compaction patterns have pointed to a renewed tightening, also not good, renewed tightening along a broad segment of the fault. Not a short one, a broad, of course. So the subtle geological rearrangement usually precedes long-term buildup. So it's not predictive on its own, but it aligns with the other indications that are showing that the whole system there is entering a more active phase. To make it clear, this sediment has offered like a quiet but a reliable signal from beneath the ocean waves. That's not it. There's more. Coastal land surveys, guys, they confirmed slow subsidence along the key zones. So you might wonder, so what is it? I thought the land was rising. Well, wait for it. We have communities along the Washington and Northern Oregon coastline. They have recorded a slow but a consistent subsidence as the edge of the converging plate sagged under accumulating strain. So this downward movement of the sagging plate, this one here, reflected that the plate is being drawn towards the fault interface as pressure mounted beneath it. That measured subsidence was small enough to miss without specialized instruments, but it's meaningful enough to raise the alarm. Scientists are saying this raises the alarm amongst geologists, and then also my alarm as well. So the sinking coastline matched deformation patterns again seen before large subduction earthquakes in Japan. We have data from other disasters. They have already been through this, and they're really good prepared compared to the West Coast. But not only Japan, it also matched patterns, deformation patterns before large subduction quakes in Chile, for example. The trend has placed the region on a familiar trajectory. Not good, guys. But there's more. I have to say it again. Energy release patterns have resembled early pre-quake behavior. The seismologists are tracking small microquakes beneath the region, and they noticed a shift in how energy was releasing along the plate boundary. While still quiet compared to other fault, it's still quiet. The Cascadia zone showed a changing signature that suggests parts of the fault are preparing to transition from deep tremor release to shallower strain accumulation. Also, what scientists say, these transitions often mark the approach of a new stress cycle. So, of course, the scientists can't give us a timeline from the data that they have from that puzzle, but they recognize this pattern, this whole puzzle from other subduction zones so that they can give us a warning. It marked a subtle but meaningful change of the fault's internal rhythm. So the problem is, what we can say is that the Cascadia Fault's renewed activity signals a long overdue awakening. After centuries of silence, now the Cascadia Subduction Zone is showing signs of movements that the researchers just cannot dismiss as all normal, all good, nothing to see here. The fault has always operated on long time scales, and that's the problems, right? There were calm centuries that have masked the extraordinary power that the Cascadia Subduction Zone has. The recent signals, they do not guarantee an imminent rupture, but they indicate the system is shifting into a new state of tension. Communities across the Pacific Northwest, they really depend on understanding these changes, and they really should even escalate the preparation with building codes and safety measures, because the new data points to a fault that is slowly preparing for another chapter in its long geological story, and that new chapter is not going to be a good one. So the silence that has once defined Cascadia, makes it so beautiful to live here, is beginning to break. And the region's future is now defined by what comes next. And it's only a question of when, not if. It will happen again. Guys, I hope you liked this video. Leave it a hype and a like. If you're interested in stuff like this, subscribe to my channel. If you want to support the channel, link is in the description. Thanks for being a member. Thanks for your supers. And check out the videos in the end screen or my start page. Check the videos there. I hopefully see you in a second if you click one of the 4 videos here. Thank you so much. Stay safe.